Hi! In this series, we'll be going through the GCE Singapore H2 Math A-Level paper for 2022, and in this video, I'll go through the first 4 questions for 2022's H2 Math paper 1. So, what I'm trying to get from this series is show students how to go through step-by-step thinking processes to arrive to the solutions for every question. And I'll go with you in depth into what each step represents. So let's begin with question 1. So basically, it says you have the following equations over here and you're supposed to find Z and W. The idea of this question is to solve for a simultaneous equation where the variables are complex numbers. And so you just need to first write down the equations, get a good look at it. And it is just like solving a normal simultaneous equation when you have real coefficients. Just imagine this is 3 and this is 3. It's the same thinking. So what you want to do is eliminate one of the variables first. And so you take equation 1, you times I over 2. So that you can get this IW, which you can then use to take 2 minus 3 to eliminate it. What you result is this equation 5 over 2 minus I times Z equals to 6 plus I over 2. So the idea now is just to divide it over. So you first multiply by 2 on both sides so you get good whole nice numbers. Then you divide it over and you get this. And then you just want to learn how to simplify this, and you realize that you can simplify this by multiplying the top and bottom by the conjugate of this complex number, so which is 5 plus 2i. Doing so, this bottom will become a real number and you reduce it further and you get 2 plus I. So now you know that Z equals to 2 plus I. You can sub it back into equation 1 and solve for W. So this part is just solving for W, and it gets you that W equals to minus I. So I hope you can follow this along, as the key concept for this question is to solve a simultaneous equation with complex over the complex numbers. Moving on, we have question 2, which tests you your ability to differentiate functions. So you got fx equals to tangent inverse square root 2 plus x. Again, what I like to do is just write it out what they are given us, and then they ask you to find f prime x. So you just need to differentiate this thing, and you can use your memory or MF26 to see the differentiation for tangent inverse x. So we know that if y equals to tangent inverse x, dy dx, which is the derivative, will be 1 over 1 plus x squared. So now in our case, this x here is square root 2 plus x. So it's the same idea. So just go 1 plus over square root 2 plus x squared. But now the thing, this is no longer just an x. So you need to use the chain rule to differentiate the inside. And differentiating this, you see, is just 1. So expanding out and simplifying, you get the following. As for f double prime x, you just need to differentiate this part. And again, the idea is this portion can be treated as 3 plus 2 square root 2x plus x squared, whole thing reciprocal. So you know that the derivative of y reciprocal is minus y minus 2 because you bring down the power. Now this whole thing is your y, and so you just need to bring down the power, this thing raised to minus 2. But because now this is not just a y, it has many terms, you just need to do the chain rule again. And you get the following, this additional portion, which then leads you to this final result. And so that's how you do this portion 2 part A. And part 3 is asking you to find the Maclaurin series. And basically the Maclaurin series is approximating this function fx near the point 0 with a polynomial. So you can imagine, I'm not sure how the graph will look like, but you can imagine it to look something like that. And you just want to find the point near here. So you're just like taking a bending ruler and polynomial in that case and approximating the function. And to do so, you just need to sub in, well, the function at 0. So you need to find the f0, f prime 0 and f double prime 0. And the formula for it will always be f0 plus f prime 0 x plus f double prime 0 over 2 factorial x squared plus all the way. So that's the Maclaurin series formula expansion. And so you just need to sub in these values and you're done. Yeah. So we'll move on to question 3. And question 3 is testing you whether you know how to differentiate parametric equations and combining it back to form the derivative dy dx. So again, like I always say, just write out what you know, which is these two given. And they say find the gradient of the normal. So you know that the gradient of the normal is minus 1 over gradient of tangent. And we know that the gradient of tangent can be used, you can use dy dx to help you find it. So we need to find dy dx. And basically dy dx is just dy dt. So you differentiate with respect to t, then you multiply the derivative of dt with respect to x. So dy dt, you just need to differentiate normally and you should get this result. As for dt dx, it's just reciprocal of dx dt. So you already know how to find dx dt, which is 1 over this whole thing. So it's just differentiating this with respect to t. Then what you want to do to find the gradient of the tangent is sub in t as 1/3 ln 2 and you get 3. So the gradient of the normal has to be minus 1 over 3. I hope it's clear so far. If you have any questions, you can leave it down in the comment section and we'll answer it. So for 3 part B, now they tell you consider x squared or my squared or otherwise to find the Cartesian equation. And then state any restriction of the values of x. So basically, they already told you to consider x squared and y squared. So let's just do that first and see whether it gives us a possible alternative if we cannot use x squared and y squared. So just take x squared and you get this following. So how do you square of this? Well, e3 when you square it is e3t times 2, not square. So it's e6t. Then this part will cancel out, so you just get the 4. And this one you square it again normally. And the top you just times 2. Then same for the y squared, you get the following. And you see that x squared and y squared, if we take x squared minus y, we get to cancel off this e and this portion. Similarly here. What we get is some constants, which is very favorable. And so let's just do that. X squared minus y squared. So 1/4 times 4 is 1. 1/4 times minus 4 is minus 1. But because of this minus, it becomes plus 1. And you get 2. Hence, this is the Cartesian equation that you want. And now we need to restrict values on x. Because you are using a parametrization, you need to look at the parametric version, what values it can take and what values this can take. So let's just see. Y squared must always be larger than 0. And so for x squared minus 2 to be equals to 2, it must mean that x squared must be at least 2. This results in x squared being larger or equals to square root 2, or x being less than or equals to minus square root 2. So a lot of students will stop here. But if you realize from the parametric equation, because the parametric equation is something that you must sub in, so t ranges through all real numbers. So you run through all real numbers, you realize that x will always be larger than 0 because e is larger than 0. So exponential is always larger than 0. Even the reciprocal of it will also be larger than 0. Then this whole portion will always be larger than 0. And that means we have to reject x is less than or equal to minus square root 2. Hence, the only restriction is x being greater or equals to square root 2. I hope it's clear. And what this question you really need to take note is realizing that the parametric equation also imposes certain restrictions on the values of x. So you got to check that for that too. Next, we'll move on to question 4. And for question 4, again, is asking you for your techniques of differentiation and integration. So, first, we just need to differentiate cotangent x. And, well, cotangent x is 1 over tangent x. So, bring down the power. So, here should have a minus 2. Then, differentiate the inside, which is tangent x, so is secant squared x. Secant squared x is 1 over cosine squared, and the bottom here is sine squared over cosine squared. These parts get cancelled out, so you get minus cosecant squared x. And next, you want to show that sine 2x tangent x equals to 2 sine squared x. Well, at first glance, you might think, how would you want to show it? The most natural way for me will be just write what I know I can expand. Well, I know that my sine squared x can be 2 sine x cosine x, and my tangent x is sine x over cosine x. Realizing that, you can cancel out the cosine and you get 2 sine squared x. So you've shown it. And the last part of this question is really testing you to know whether that the integration and differentiation are some sort of a reverse of each other, and how you want to simplify it is to use part B. So what do I mean by that? Well, we get cosecant 6x and cotangent 3x. This means it's 1 over sine 6x and tangent 3x. If you see over here, this is sine 2x and tangent x, meaning you can also replace this by sine 6x tangent 3x and replace this equals to 3 sine squared 3x. 2 sine squared 3x. And that's what we do. So we get to simplify it over here. And then we realize this, you can pull out the constant, so it's half. Integral from pi over 18 to pi over 9 is cosecant squared 3x. Then you see, over here you have minus cosecant squared. So you put a minus sign here, meaning you have to put a minus sign outside as well. And with that, this is the derivative of cotangent x, or cotangent 1/3 cotangent 3x, in a sense. Because when you differentiate this now, cotangent x, you have to differentiate the 3x. So it will be the 3 and 1/3 will cancel out. So you know that it's 1/3 cotangent 3x. So when you integrate it, it will be this antiderivative. And then you just need to sub in the values and you get the following answer. So I hope these 4 questions are clear for you guys. In my next video, I'll be going through the next 4 questions. So stay tuned for that. And if you have any questions about these 4 questions, please leave it down in the comment section below. Thank you. See you again. Bye.